Nama saya Ajay Doshi dari Google Cloud Malaysia. So actually ni bukan first time saya kat UKM lah. Pernah datang beberapa kali juga, tapi first time coming as a speaker, as a presenter. So saya nak ucapkan terima kasih lah for the organisers for having me here today. And topik saya untuk hari ini, saya just nak share a bit of high level and introduction on the topic of HPC. Ataupun nama the long term for it is High Performance Computing. So tuan-tuan puan-puan pernah dengar tak perkataan HPC atau pernah work on HPC ke, ada buat projek HPC atau pernah dengar tak perkataan tu? Siapa-siapa? Just yes or no je? Tak pernah Okay, tak apa. Tak apa. So hari ni kalau boleh I just want to give you guys an overview. So HPC ni mungkin tuan-tuan puan-puan familiar dengan konsep server and client. So saya sebagai client, saya nak pergi My Sejahtera contohnya. Ni cerita tahun lepas lah, kita nak buat check in kan. Nak masuk kedai mamak ke, masuk shopping ke, first kena scan. So what is actually happening in the background? Dalam phone saya akan scan tapi request goes to a server. Server tu buat kerja mudah je. Dia just nak tengok kedai mana and siapa. Is it me? Is it somebody else? So yang tu kita panggil typical server client punya behavior. Tapi kalau kita bayangkan, kalau kita nak buat something way more complex, kita nak buat research, kita nak buat financial analysis. Kita ada banyak data and kita nak buat analysis on that set of data. Ni macam beberapa terabyte lah atau beberapa petabyte. So boleh bayangkan resources yang dia perlukan tu compare dengan My Sejahtera is maybe 0.1% of what HPC can actually do. So kebanyakan use cases untuk HPC, especially in universities, dia banyak untuk faculty research lah. So kalau untuk UKM ada faculty research yang dia nak buat analysis of historical data population Malaysia sejak tahun 1900 contohnya. So there is a lot of data to go through. So kalau boleh tak kita buat dalam Excel? Boleh tak kita buat filter? Jawapan dia tak boleh lah, dia akan makan masa yang lama. So high performance computing is usually melibatkan data yang luas, yang banyak data. And the other concept is dia memerlukan intensive CPU cycle. Walaupun hari ini kita ada powerful iPhones and Androids, there will always be a limit yang ataupun cabaran lah dalam dunia IT ni on the processing yang kita nak buat. Contohnya dekat NASA, dia nak buat drawing of a black hole. Just for that, it actually takes a lot of computational power, raw computational power. So that's where HPC comes into the play. So apa yang Google Cloud buat dalam this area ataupun this sector ni, kita akan provide customers with a way to run their HPC workload. So tak kira lah kalau tuan-tuan perempuan belum identify ataupun dah ada sekarang something you guys are doing, ataupun you guys baru nak plan, nak kata okay, I have this data ataupun I have this requirement for research. How do I actually, macam mana saya nak buat HPC? Where do I start? So that's why kita akan usually guide the customers lah, such as yourself, to onboard, to show you how does it work. And then kita akan identify jugalah apa software yang diperlukan. Sebab HPC, kita ada the hardware layer, which will do the actual work, CPU, memory, storage. That one I'll explain more. Tapi atas dia ialah software. Software yang akan interact dengan the hardware. Dia akan buat scheduling ataupun processing. Macam mana kita nak run this application or this code on our very, very large hardware. Ni to relate it back to My Sejahtera, software yang kita guna ialah web page. Could be Apache Linux, could be any of your open source ke apalah, it depends on you. So similar concept dia, cuma scale and computational power is different, that's all lah. Okay. Clicker tak jalan. Sorry, can you go back one slide? Okay. So basically for today, saya akan explain in terms of 4 key areas. HPC ni dari 4 aspek, the 4 main aspect lah. First thing is compute, like I mentioned earlier. Macam mana resources yang kita ada, how do we size the resource based on the requirement. And then of course we have our storage, the data, actual data yang kita akan feed atau provide to the HPC service. How do we actually design it? As well as the network. So network pun penting, especially in the cloud world. kan. So contohnya hari ni kita dah start dekat Singapore contohnya, and we want to extend, we want to have another cluster dekat anywhere else in the world. Contohnya dekat US, kita ada collaboration kan dengan universiti kat US ke kat Australia. So we can actually spin up lagi satu cluster tu dekat tempat diorang lah. Walaupun data we can openly share, tapi kalau diorang nak buat research, kita nak extend model yang UKM dah buat sekarang ni, we want to showcase to the other universities, how do we do it? Kalau cara kita nak buat sekarang, mungkin kita akan host dalam data center dekat PTM ni, kan? Tapi for HPC, it's a very high cost. Spec yang kita guna tu is, boleh kata is quite astronomically high lah, sampai berjuta-juta just to buy one stack. And nanti I akan explain how does this stack compared to running in Google Cloud. And of course, tadi I mentioned HPC software. We are coming mainly from the infrastructure side, tapi we also have a good integration dengan HPC software macam Slurm dan sebagainya. Nanti I akan share list lah. Okay, so commitment daripada Google Cloud on HPC actually started quite some time ago. Okay, continuously every year kita ada lebih banyak offering yang kita offer for our customers. So at the beginning we started offering GPUs, so graphic processing unit. Yang ni kalau kita nak buat banyak AI atau machine learning, mesti kita akan guna GPU kan. So dulu we used to offer Nvidia and Intel. Lepas tu bila Google came up with their own machine learning punya solution, TensorFlow, kita started using TPU, Tensor Programmable Unit TPU ni. So TPU is a custom GPU developed by Google lah. Mungkin tuan-tuan pernah dengar TensorFlow and so on. So it's actually running on that. Walaupun yang ni internal dulu Google yang buat, sekarang kita dah offer to our customers as well. So because in some most use cases it's more efficient. And then of course we fast forward to today, we also support AMD punya CPU. So kalau tuan-tuan familiar, usually CPU ada dua vendor lah, Intel dengan AMD. Intel is most widely used on your PC, on your laptop. Tapi AMD ada juga kelebihan dia sebab dari segi number of cores and the clock speed, usually dia lebih higher lah, better than Intel. So kalau customers yang dah buat sizing atau familiar dengan AMD, we also offer AMD. Then of course we have the software services and tools, the middle layer, like I mentioned tadi, this is the infra. And as well as the partner solution. Sebab kalau kita buat HPC, it's not just having your one rack of all your servers. You can ada software, you can ada integration, you can ada cara untuk bagi your researchers atau users access the data. Kita tak perlu nak bagi dia suruh tengok the raw data tau. We have to find a way to present it, make it presentable. So there's a lot of things that come together for HPC. Dia bukan setakat thinking about the infra, you also have to know what is the research punya purpose, who is the user. Kebanyakan masanya, once analysis dah done dekat our HPC cluster, we will share out the report ataupun kita akan share, we'll publish the data openly lah, open data yang kita panggil, macam what DOSM is doing, Department of Statistics kan. Kalau tuan-tuan pernah pergi Open DOSM punya website, they have all the statistics, open data available. So usually that's the case lah yang kita buat dengan HPC. Okay, so just to spend a bit more time on the infra, on the compute side, sebab I think it's very important to understand what actually makes HPC possible. How do we actually make it work kan? So dekat Google Cloud memang we have a wide offering of compute services ataupun panggil virtualization. So starting from cost optimized sampai ke performance intensive. So usually kalau kita cakap pasal HPC, we will be looking at these two areas lah. Best performance for workload and highest performance CPU. So kita ada macam dua family dia lah, Tau and also C. So yang ni just offering yang Google Cloud ada for customers. Contohnya kalau dia just nak run a simple app, website, MySejahtera ke database, we will go with the N or E series. Tapi if you look at more intensive workload, we will go to the right lah. So we have something for every requirement yang customers kita ada. And then for HPC specifically, just nak share for your information, specs yang kita provide boleh nampak lah berapa bilangan core dia. This is actually very high. And kalau kita bandingkan kita nak beli satu server ni, pasang dalam rack, think about the fact that server ni akan last maybe 3 to 5 years before you guys kena refresh. and then also you guys kena maintenance. And bila masa kita beli tu, we are paying the full price for it. Walaupun kita hanya guna 5 jam sehari. Takkan ada orang guna 24 jam sehari, 7 days a week. So the cost yang kita spend to buy that rack of server already there. Tapi utilization, especially if you're just starting off, you will never ever need to use that much. Not at the beginning. In fact, siapa yang buat 24/7 HPC, I can think of is maybe orang-orang kat NASA tu lah, sebab dia orang banyak projek kan. So it makes sense for them. Tapi customers yang tak perlu this kind of, dia perlu the capability for a short amount of time. Dia tak perlu nak run dia for 1 month. So this is where cloud can help offset the cost punya perspektif. Setakat lama yang saya guna, that's how much I pay for. And if I use it, hari ni saya guna, besok saya tak guna, I have that cost saving. It will always be cheaper than buying your own hardware. And this is the direction most of the organizations, universities are moving towards. Kita panggil operational expenditure rather than capital expenditure. So it's more efficient on our budget. So senang kita nak plan and so on. So that's a bit of backstory lah. So kita ada N series and C series. The main difference is on the C series we have specific technology, non-uniform memory access. Yang ni lebih kepada cara CPU boleh provide performance to the application lah. So dari segi architecture, if your requirement or workload is very intensive, you will usually go to the sebelah kanan lah, workload optimize, the C series. So sekarang baru-baru ni we have actually introduced C3, slightly higher spec, sebab memang ada banyak requirement untuk HPC. Banyak customers are already doing it today in Google Cloud. So tuan-tuan kalau familiar dengan spek laptop ke server, boleh bandingkan ni lah. This is what we usually talk about when we talk about HPC. It's a totally different scale and performance. Okay, dari segi storage, so storage pun penting sebab kita nak buat processing tapi kena ada data. Kalau tak, dia akan just run and then tak tahu dia buat apa kan. Dia kena ada tempat untuk read and store the data. Kebanyakan masanya, customers yang nak guna cloud untuk HPC, most of the time dia dah ada data dia. Dia mungkin store dekat data center dia. Dia memang have records of contohnya senarai pelajar atau senarai financial records or something like that. Mesti dah ada lah. So what we will do is basically kita akan cari find a way for them to migrate the storage to cloud. Sebab kalau storage kat DC, HPC dekat cloud, there will be a very significant latency atau delay. Sebab dia nak read write, it doesn't make sense lah. You should actually move it to the cloud. If the data is sensitive, contohnya ni data senarai warga-warga Malaysia, ada address, IC number. So yang tu data sensitive, tak boleh letak dalam cloud. So kita ada solution untuk tokenize atau anonymize the data. Maksudnya kalau IC nombor saya masuk kat cloud, mungkin saya daripada 6, 2, 4 digit kan dia punya format tu, kita boleh buat hashing. Bagi dia 10 hexadecimal contohnya. So once kita dah buat hashing tu, baru kita upload dekat cloud, we are compliant sebab tak ada apa-apa data yang personally identifiable information, PII. So yang ni lebih kepada konsep storing data in the cloud, tapi we have a solution for that. Walaupun it is very sensitive. Contohnya bank ni selalu sangat protective over their data kan. Kalau cakap cloud je, okay, dia kata bye-bye. Tapi we have come up with a solution for that. So it doesn't matter if your data is sensitive or non-sensitive, the solution is there. So kebanyakan masanya we will talk about cloud storage ataupun persistent disk. Maksudnya kita attach storage pada VM, this is very traditional, ataupun guna NFS lah, using file store. So yang ni lebih kepada the architecture aspect. Tapi kalau contohnya sekarang kita dah guna vendor lain punya solution for our data, mungkin we have few hundred gigabytes or terabytes of data, we actually can we have a partnership with these companies. Kita boleh directly access dia punya solution lah. They have their own way to move the data to the cloud. And then on the right here, these are actually Unix-based file system dari Intel and IBM. Sebab these companies sebenarnya diorang dah ada their own HPC solution, tapi dia focus on the storage. Because I mentioned tadi, HPC is not just about processing your data, processing the information. You kena ada tempat read and store the data. And this is, the scale is enormous. Dia bukan setakat storing in your phone ke apa. There's a lot of data. So kalau tuan-tuan familiar dengan HPC, mungkin pernah dengar some of these names lah. So we have the integration all the way up to this level and also the basic level. Just starting off with simple storage. Okay, so peranan network pun penting sebab if you think about it, contoh yang saya bagi tadi tu satu server, realistically you won't have one, you will have many, mungkin up to 20 servers. So you kena find out a way macam mana nak make them talk together. So in a typical data center environment, you akan ada switches lah. You akan connect all your server to the switch. Bila server A nak cakap dengan server B, dia tak direct sebab you ada 20 servers. Dia akan lalu switch akan send info to the correct server. So dalam cloud pula macam mana? Sebab kita tak nampak, kita tak tahu pun dekat rack mana, dekat server mana our workload is running. UKM punya workload dekat mana kita pun tak tahu. So what happens is Google actually provides that infrastructure. Kebanyakan masanya we will only run your workload in one region. Contohnya dekat Singapore. So everything is happening there and networking tu automatically dah buat. Kita just kena bagi permission lah, set policy and they will automatically talk to each other. So yang ni just for your information, mungkin tuan-tuan puan-puan pernah dengar Google ni banyak ada submarine cable. Under the sea, submarine cable lah, subsea cable, sorry. So, cable ni, kenapa Google spend so much of money investing in this cable? Sebab traffic dalam Google Cloud, antara satu region, antara user ke siapa, it doesn't go through the internet. It goes through Google's punya network. So, network kita sendiri, which runs worldwide. So, bila tuan-tuan puan-puan masuk YouTube, masuk Gmail, masuk Google Photos and so on, data tu sebenarnya is traversing through here. That's why siapa sebelum ni pernah, in the last 5 years, bila masuk YouTube ada lag, video tu tak load. Bukan sebab wifi assuming your wifi was okay. Tapi ada tak tuan-tuan perasan, video tu load kena tunggu, buffering. Mungkin 15 tahun lepas mungkin ada, tapi sekarang the investment that we've made, we have practically connected the whole world. So contohnya kalau nak tengok some of the content yang hosted dekat US from YouTube USA, bila kita access, kita tak nampak beza dia dari segi speed and performance and latency. Because kita ada buat caching, kita ada buat CDN and so on. So this kind of investment is already in place and kita tak guna untuk YouTube, Gmail, Photos, kita sebenarnya buat untuk Google Cloud. So Google Cloud customers are using the same infrastructure as Google, our internal infrastructure lah. So this is just something yang just wanted to share. So how does it relate to HPC? Like I mentioned tadi, kalau kita ada customer dekat Europe and then university yang ada dekat Europe, dia nak reuse HPC solution yang UKM ada, contohlah. So they can immediately deploy dekat dia punya university. Rather than kita share dengan diorang, mungkin kalau diorang nak share, susahlah sebab UKM pun nak guna kan. So, and then macam mana nak buat charging semua is difficult. Tapi if UKM dah ada a solution in place, kita nak replicate. And I will share more on how to replicate. This is one way, by using the cloud and the regions that we have. So, tadi I mentioned software is as important as hardware. So, dari Google, kita tak only provide the hardware, we also have several software in place to help the adoption of HPC. So first things first, memang we work it up from the ground up lah, infra, software, to customer. Then we have something known as HPC Toolkit. So yang ni adalah jawapan kepada soalan macam mana saya nak repurpose atau spin up solution HPC saya dekat tempat lain ataupun dekat cloud lain pun boleh lah actually. Macam mana saya nak reuse, macam mana saya nak share. Kalau I have a HPC solution which my researchers use, ada requirement daripada universiti lain, daripada kerajaan lain, macam mana saya nak share. Just the software punya stack, bukan data, just the software. Mana dia punya processing, mana dia punya front end and so on. How do I replicate it? So jawapannya ialah HPC Toolkit. I will share more on that. And then on batch is actually Google punya own solution lah. Kebanyakan masanya kalau customers dah biasa guna HPC, dia akan ada their own solution. Tapi kalau memang dia starting off from zero, they can actually reuse the solution from Google Cloud lah. Namanya ialah batch. So yang ni ialah contoh deployment gunakan HPC toolkit. So as I mentioned, sekarang ni environment yang kita ada ataupun we already using, kita panggil dia sebagai blueprint. Blueprint ni kita boleh replicate and spin up dekat environment lain, dalam DC, data center kalau ada resource, ataupun dekat region lain ataupun dekat cloud lain. So what happens is, first kita akan draw blueprint, berapa server kita ada, dia guna OS apa, and basically the storage kena ada berapa size and so on. This is your HPC blueprint. Kalau you nak import from existing HPC modules daripada vendor lain atau solution HPC lain pun boleh. You just add it to your one. Lepas tu kita akan proses dekat engine. In your deployment folder, you can use contohnya Terraform. Terraform is a tool to automate infrastructure provisioning lah. Kita nak spin up satu DC, kita dah bagi dia specs. Kita punya DC, berapa CPU, berapa memory, berapa storage and so on. So same concept, kita guna untuk HPC and then we can spin it up in Google Cloud, regardless of which region lah. And then of course, sebab dia dah already in the Google Cloud, boleh make use of solutions yang kita ada lah, monitoring, analytics and so on. Basically the whole stack of Google Cloud tu, kita boleh integrate dengan HPC. So kita start dengan HPC, tapi kita guna all the other features yang cloud provides us lah. Okay, so yang ni just summarizing what I've covered so far. Apa kelebihan menggunakan Google Cloud untuk HPC. So first things first, menggunakan toolkit tu, it makes it easier to come up with a blueprint and replicate it. Secondly is open source. So apa-apa software yang kita guna, we are actually open. Kita tak dictate kena guna Google punya software. If you have something already in mind, especially if it's open source, even better. Google pun banyak develop benda open source, so it's second nature for us lah. Memang kita pun suka. And kelebihan running it in the cloud, bukan saja you pay for what you consume, tapi segala kelebihan dia dari segi monitoring. Kita tak perlu nak invest in monitoring tool. Nak tengok server tu healthy tak, berapa utilization, tak perlu. Automatically done in the cloud for us. Okay, so this is the example of batch. Batch is a workload scheduler. So contohnya kita nak buat analysis of 1 petabyte of data ni, kita akan create a new job dalam batch. So batch yang akan buat the automated workflow tu run all of this dekat cluster HPC kita. Which server akan buat processing for the first 100 GB, second 100 GB. Siapa yang akan buat arahan untuk process the data. Yang tu ialah tugas scheduler lah. So scheduler memang ada few solutions out there macam Slurm and so on. Tapi we also have our own lah, namanya batch. So ini terpulang lah kalau customers prefer to use what they have ataupun dia nak guna something native to Google. Senang sikit nak integrate. And yang ni just to give a high level overview, this is actually what a HPC architecture looks like. Okay. Maybe on premise kita ada some servers atau license server sebab some solution key license dia tu dia kena store dekat on-prem, so okay. Tapi bila masuk Google Cloud, you will always have a login node. The first node yang kita access. Kita tak directly access the cluster tu. Kita always access the, kita panggil login node lah. So this is just a very small punya VM. Actually, dia performance spec dia tak tinggi sangat. Sebab tugas dia is just to manage your infrastructure. So, kita masuk kat sini, kita boleh check what is the status of the work, status of the HPC job that is running, ataupun kita boleh create a new job to run. So, yang ni ialah tugas dia. Interactive node. Administrative node lebih kepada benda admin lah. So for today I won't cover so much. Compute node ialah node yang buat kerja lah. Basically node which will do the processing. So yang ni ialah nodes yang ada the higher spec. So as I explain tadi, kita tak terus masuk kat sini tau. Sebab tugas dia ni, dia fokus. Dia hanya buat kerja dia. Dia hanya analysis data, dia buat calculation and so on. Siapa yang suruh dia nak buat apa is back to the login node, the admin node, interactive node lah. So kita ada beberapa option like I mentioned tadi. We also have something known as spot VM. So masuk spot VM ialah kita boleh interrupt dia. Contohnya dia tengah running sekarang, dah 2 jam. Tiba-tiba kita, sebab Google Cloud punya infra is limited kan. Kita only have a few hundred servers. So, spot VM ni ialah sangat murah. Tapi the catch is, kalau kita nak ambil balik the resource tu, kalau customer lain kita nak bagi dia, we can take it. Tapi it's fine sebab bila spot VM ni, contohnya satu VM dah down sebab Google dah ambil balik, we can always reschedule sebab kita ada the login node. So dia boleh detect kalau satu server dah fail, I can rebalance, I can do my calculation again. So it doesn't mean everything fail. They actually fault tolerant. So this is HPC punya architecture. Kalau ada 20 server, satu server fail, the processing still can go on. Mungkin ada performance penalty sikit, it will only be a few hours lah. Tapi the time it takes to digest your data tu, it's still running. Dia takkan stop everything at the same time. So this is an option kalau depending on apa analisis yang dia buat. Kalau dia tak intensif sangat macam buat COVID-19 punya research and so on, if they are not doing that, then usually kita propose spot VM. It's very very cheap. Lepas Google dah ambil, dia akan return balik and then the processing can continue. Tapi it won't be for the whole cluster, it will just be for a few saja. And then dekat bawah ni of course is your storage lah, like what I explained tadi. Where do we take the data, where do we store? So ada few options there as well. Kalau most of the data sekarang ni dekat database database UKM dekat DC, kita boleh actually guna transfer service to copy out the data over VPN. So, kalau dia sensitive, kita actually have a secure way to do it lah, guna VPN. So, once the data is here, terus our compute engine boleh process the data. And then like I mentioned tadi, kalau setakat HPC, lepas kita dapatkan output HPC, kita ada data tu, we can do further analytics guna BigQuery. So, this is Google Cloud's punya one of the most prominent solution lah buat analytics. So the limit tu, it doesn't just stop at HPC. We can do so much more. You can make your data open, you can export. Mungkin kalau ni data COVID, kita boleh share kepada KKM, Kementerian Kesihatan Malaysia, directly to them because we are doing the research. So all of this actually comes together in one ecosystem lah. That's the whole idea and benefit of running HPC in the cloud. The potential doesn't just stop at doing HPC alone. So yang ni satu contoh yang saya dapat cari of our existing customer. Yang ni kat US, University of South Carolina. So tuan-tuan puan-puan boleh tengok dia guna sampai 4,000 nodes. So kalau nak bayangkan 4,000 servers. So mana dekat sini mana kita nak store that many servers. Macam mana nak buat cooling, nak buat cabling, nak buat maintenance, nak buat management. Tapi like I said all of this ni dia tak guna untuk sebulan atau 7 hari. Dia hanya guna setakat mana perlu saja untuk buat the processing. Once dia tak guna, dia power off and for them they are not charged. Dia tak dapat billing sebab dia tak guna dah. Jumlah CPU core yang dia guna adalah sampai 125,000 CPU core alone. So this workload, if I remember, yang ni untuk microbiome sequencing lah. Yang ni lebih kepada healthcare punya ni. Dia buat DNA punya sequencing. Memang this is one of the use case for HPC. So tuan-tuan puan-puan boleh tengok. Dia start pukul 4 petang processing dia. And then pukul 8 pagi the next day, dia dah stop. So dia hanya bayar untuk dispatch of time. I don't have the exact cost tu berapa, tapi boleh bayangkanlah how does it compare to running your own cluster on the DC. I think I said that a few times already. Dekat sini pun dia guna preemptible VM. So sebenarnya in actual fact yang ni dia ada drop sikit lah. Tapi it doesn't change the fact that they only consume it for less than 24 hours for processing. And then this is the architecture yang diorang guna. Diorang tak ada data dekat DC, semua data dekat cloud. So user, saya guna laptop, I just pergi dekat login node, saya nak tengok what is the status of the jobs, kalau dah habis ataupun saya nak run a new job. Lepas tu dia pakai Slurm controller is the one yang akan distribute the work. server mana yang, out of the 4,000 servers, macam mana saya nak distribute the workload to 4,000 servers ni. So, boleh nampak kat sini, dia ada sampai 4,000 instances. Dalam dunia cloud, instance boleh bayangkan dia sebagai satu server. Tapi in reality, kita pun pecahkan satu physical server to a few pieces. Mungkin hari ni dia buat kerja HPC, besok dia digunakan oleh customer lain untuk buat website hosting ke apa. So that's how it works in the cloud world lah. So apa-apa processing yang dia buat, dia akan write kepada cloud storage in the cloud as well. And then kalau dia nak retain some of the data for future analysis, dia akan simpan balik dalam persistent disk untuk future analysis to be used by the worker node. So this is one simple but complete solution. This is how simple it looks like lah. This is an actual solution lagi. Okay, itu saja. So I think saya tak sampai setengah jam pun. Tapi kalau ada Q&A, ya, thank you.
Terima kasih saya ucapkan kepada Encik Ajay Doshi atas perkongsian yang berilmu dan berinformasi sebentar tadi. Kini tibalah masa yang dinanti-nantikan. Jika ada sebarang soalan yang hendak diajukan berkenaan sesi Pocket Talk sebentar tadi, saya membuka pertanyaan soalan daripada hadirin semua sebanyak 3 soalan. Para hadirin dialu-alukan untuk mengangkat tangan untuk menanyakan soalan.
Sorry? Notes. N-O-D-E-S. So nodes, kita boleh panggil dia sebagai one server. Graph tadi kan 4,000. Sorry? Tak, dalam cloud like I mentioned, dia is not actually one server. Mungkin sebab Google Cloud punya site, satu server yang kita host dekat Google Cloud tu, dia sebenarnya mungkin can go up to 20 nodes. Sebab kita akan pecahkan dia. Walaupun satu node ada 200 CPU, that whole server can host way more. So it's all about cutting, packaging it lah, smaller and smaller and smaller. So yang graph tadi tu, it actually represents nodes actually represents the instance that is running the job. Satu instance dia akan ada 100 CPU, 1 terabyte memory and so on. Satu node tu. CPU. Dalam node, satu node, macam CPU ni mungkin ada 8 core. Tapi this is a standard CPU. Dalam HPC, dia akan ada satu node pakai beberapa ratus core. Kalau guna AMD lebih tinggi lah. Kalau guna Intel maybe up to 90 cores or so on. So that is the correlation. Kenapa dia emphasize on cores? Sebab it is actually one way to measure HPC workload. Contohnya kalau saya nak buat microbiome sequencing ni, dalam dunia HPC dia akan cakap lah, oh yang ni kena ada 100,000 core. Contohnya kalau saya nak buat financial analysis, mungkin saya perlu 50,000 core. It's a way to do sizing untuk for the team to understand berapa scale yang diperlukan untuk infrastructure diorang. So that is the relation between core and node. Node can have few hundred cores. Macam tu lah. So that's why usage dia pun, the graph I hope is not confusing. Tapi dia just nak tunjukkan on the on-premise punya world, kalau kita ada dalam DC hari ni UKM punya DC, yang ni ialah start daripada time bila kita beli hardware. Yang ni ialah time yang kita refresh hardware. Mungkin 3 tahun, 5 tahun. Graph ni dia tak akan jadi macam ni. Dia akan ada spike, hari ni guna, besok tak guna. So, walaupun kita dah beli dia, the line will stay flat most of the time, unless kita really buat benda intensif lah, which I doubt. So in DC world, or kalau kita nak buat HPC sendiri, kita beli hardware, hari ni guna, besok tak guna, besok guna 2 hari, lepas tu drop. So utilization dia tak akan, this is like almost 100%. So customer ni University of South Carolina, dia pay for how much yang dia guna, itu saja. So tuan-tuan puan-puan boleh buat bandingan lah. Is this going to be cheaper than paying for 5 years upfront. Simple economics lah. Yeah, so this is the point yang kita nak share lah. Berapa core and nodes yang dia guna is actually setakat apa yang perlu. Kalau contohnya hari ni dia start, dia tak cukup 2000, dia nak up lagi, kita boleh provide as much as they want. So that is the whole idea of cloud computing lah. Yang ni bukan konsep HPC pun, yang ni konsep lebih pada cloud lagi. So memang it's very different, I would say. Cara kita nak imagine how we are doing it today with servers and so on. Cara yang kita buat dekat cloud is lain sikit. Sebab we want to optimize cost. So kalau kita fikir optimize cost, kita kena ubah cara yang kita buat planning. So there's no such thing as kita beli walaupun tak guna, is still there. Dalam dunia cloud tak ada lah. So that's how we help customers save cost, optimize cost. Yeah. Sorry? By usage, betul. Kalau tak guna, memang kosong. Walaupun hardware tu dah ada, tapi Google yang bayar untuk dia, kita tak charge pada customer. Kita dah ada, kita akan provide kepada customer lain. So that is the whole concept. Kita buat abstraction dari segi managing the infra. Customer tak perlu manage, kita yang manage. Kita charge based on how much you guna. Kalau contohnya dekat Singapore ada beribu-ribu server ni, tapi just so happens bulan ni satu customer pun tak buat HPC. So siapa yang rugi? Is it customer ke Google? Actually it's Google lah. Tapi we don't pass down the dia bukan maksudnya next time bila you guna kita charge you higher, tak ada. The rate is always fixed. Tak pernah ubah lah. The rate actually is based on what is the spec you are using. Kalau spec dia tinggi, cost dia mungkin 20 sen per jam. 20 sen USD per jam. Contohlah. And then it goes beyond that as well. Kalau kita commit to use for contohnya 3 hari. Macam UKM cakap 3 hari memang saya kena buat. Dia akan dapat diskaun. Sebab kita tahu rather than not letting anyone use, kita ada satu customer yang nak guna, kita boleh bagi dia diskaun. Saving yang kita dapat actually we pass down to the customer. So dari segi economics yang tu ialah beza dia lah. Kalau ya mungkin kalau next time saya ada masa saya boleh present lagi on that aspect. Tapi again you have to switch your perspective daripada how you are looking at it as how you're looking at it now. You only pay for what you use, how long you use. Itu tadi. Ya. E-learning ya. Deep learning ah. Ya. So customers, sebab tu one of the slide tadi saya ada tunjuk beberapa peta tu. Actually it refers to the flavor yang kita ada for HPC. Kalau customer tak perlu, sebab customer dah buat sizing, kita dah tahu dah, okay, for this workload I only need 6,000 core. Ni 60,000 sorry. Okay lah, realistically mungkin 10,000 core. So cara saya nak plan macam mana saya nak consume tu is up to me. Either I can use fewer instances with smaller cost ataupun fewer instances with more cost ataupun more instances with lower cost. So dari segi costing sebenarnya is cheaper if you use higher instance, tapi bilangan instance tu kurang lah. Rather than you have so many instance and lower number of core. And also licensing is another factor. Kalau tuan-tuan puan-puan familiar, some of the OS atau solution, cara dia kira berapa nak bayar, how much you have to pay for licensing is based on number of core. Storage pun ada, storage is for storage solution, tapi processing. Contohnya, example yang paling lama ialah Oracle lah, Oracle database. So cara dia charge license ialah, server yang kita run database tu berapa core. Kalau 8 core, you kena bayar cost of 8 cores. Windows server pun sama. So boleh bayangkan, kalau kita nak save money on licensing, kita akan kita akan guna instance yang ada bilangan core yang rendah. So ada banyak cara lah, kita boleh mix and match. Tapi of course we will advise based on the best scenario lah, on the cost, on the performance and so on. Usually proposal kita akan bagi beberapa option sebab yang ni, this is not the only cost. You akan ada storage cost, you akan ada licensing cost. So overall tu, how do we actually help you all optimize? So that is cara yang we will look at it lah masa kita buat proposal nanti. Yeah.
So I have a question.
Okay, sila.
Saya tak berapa tahu sangat pasal ni, tapi ada tak kompetitor lain selain Google yang introduce this kind of service tu, and what do you see in the future of HPC?
Okay, good question. So saya rasa servis HPC dalam cloud ni bukan Google saja yang buat lah, sebab konsep cloud to run your workload, to store your storage ni, ada banyak benda yang kita boleh buat. Kita boleh buat HPC is just one of it. Kita boleh buat data analytics, yang tu cerita lain. Dan kita boleh buat machine learning, AI and so on. So HPC is just one of it. So sebagai cloud company, kita nak make sure apa-apa yang customer nak buat, daripada cost saving of paying as much as you use, kita nak apply to as many scenario as possible. Nak host website, nak buat analytics, nak buat email server ke apa, kita nak pass down the cost saving. So to your question, memang a lot of vendors are doing it lah, bukan saja Google Cloud. The differentiator is Google Cloud is very open. Macam apa yang saya share, one of my first few slide, TPU, TensorFlow Processing Unit, developed internally by Google. So vendors lain, dia tak ada solution yang dia buat sendiri. Mungkin dia beli company lain ataupun dia guna what is already out there. Google Search, kalau tuan-tuan puan-puan pernah guna, just search for anything, search UKM contohnya. Boleh nampak berapa ribu results yang dia create and berapa lama masa. Ada tak siapa-siapa perasan? Kalau kita search apa-apa dalam Google Search, dia ada tulis how many million result in how many second, and tak sampai satu saat pun, mungkin beberapa microsecond. So teknologi tu sebenarnya namanya ialah spanner, cloud spanner. And cloud spanner is a solution yang kita ada dalam Google Cloud. So that is how we differentiate ourselves. Apa yang kita dah guna, contohnya Kubernetes engine, Google Kubernetes engine. Dulu kita buat internally. Kita tak pakai VM. Kita use something more efficient. Sekarang kita nak, kalau customer nak pakai Kubernetes, boleh tak? Boleh. Same thing, kita replicate out, kita offer to our customers. So second part of your question, what is the future of HPC? I think dengan adanya cloud, it takes away a very big barrier, which is cost. Sebelum ni kalau kita nak buat HPC, kita akan dapatkan anggaran atau sizing harga. And then most of the time dia tengok harga, dia cakap, tak boleh lah ni. It won't go through. It's very hard to get approval. And especially coming from research. Kebanyakan masanya, some people will look at the cost and the benefit atau the value. Untuk research, the benefit is not monetary. Kita tak boleh measure gunakan duit. Tapi it can actually save lives and so on. So, kebanyakan masanya, a lot of HPC punya project dia tak boleh jalan sebab the barrier of price. So, dengan adanya cloud, we are indirectly solving that problem. Cloud dah ada for a very long time. HPC, maybe just 5 to 10 years ago in the cloud. So, we are already addressing that problem. So, what is the challenge yang kita nak cuba solve sekarang? Is to help as many customers yang nak buat HPC, walaupun dekat universiti, dekat pihak kerajaan atau sekolah ke apa, if there's a use case, we want to make it easier for them to do it. We want to make it possible without having to invest in berapa server? 3,500 server contohnya. So you can get the same outcome and you only pay as much as needed lah. Yeah. So any other question?
Tak ada. Okay. Jika tiada lagi sebarang soalan, dengan ini saya menutup sesi soal jawab bagi sesi Pocket Talk